trace the curve x cube plus y cube equals to 3 into axy, right, where a is a constant, x, y are the coordinate axes. Okay, so this is the basic idea. Whenever we want to solve, say, the question on tracing of a curve, the following steps will be useful, right, irrespective of the question. Okay, so we solve this in steps. So step number 1 is you always try to look at the symmetry. So I'll call this step number 1 is tracing the symmetry. So the basic idea is that you always look at the highest power of x and y in the given curve. Okay, so the idea is if the highest power of x is even, right, if I can see this, then this implies the curve is going to be symmetric about, so if the highest power of x is even, then this will be symmetric about y axis, the other axis. Okay, similarly, if the highest power of y is found even, right, if this is the case, then the given curve is going to be symmetric about, right, the x-axis. This is the point. Now I can see that highest power of x is 3, highest power of y is also 3. So this particular curve is neither symmetric about x-axis nor symmetric about y-axis. Okay, so that's clear. Now there has to be other case. If this is not true, then I will check for, right, if f of x comma y is equal to f of y comma x, this implies the given curve is symmetric about the straight line that is y is equal to x. Now, so since the first two conditions are not satisfied, I will check the next case, that is whether f of xy becomes equal to f of yx, right? So what I do, I try to write the function x comma y. This means it is a given equation. I don't have to change anything. It's simply x cube plus y cube. Okay, let's call the given function as 1. Okay, so x cube plus y cube is equal to 3 into a into x into y. Similarly, now what I do, I write f of y comma x. This means replace x by y by x. So this becomes y cube plus x cube is equal to 3ayx. So call this is 2 and call this is 3. Right? So now I can see that equation 2 and 3 are same. Right? So I can write, since equation number 2 is equal to equation number 3, this implies, right, the curve, what is the curve? Curve number 1 is, now I am going to give a comment. This is what I found out. I traced this. So the curve 1 is symmetric. It's symmetric about, right, the straight line y is equal to x. So I understand that, okay, this is what is the present situation and the given curve is symmetric about y is equal to x. Okay, so let's draw. Whatever, as soon as you understand something, it's better to draw. Okay, so let's draw something. So if I say this is my x and this is x, and say this is y-axis, and now what I want to draw the curve which I identified, that is y is equal to x. Okay, so y equal to x curve will be somewhat like this. Okay, so this is the curve y is equal to x. So now whatever curve we are going to draw, that curve should be equal on both sides of this curve. If I draw a line here, it means a line will come on this side as well. That's what is meant by symmetry. Okay, fine. So we understood now. Anyway, we cannot draw the graph now because we don't have any other details other than the curve is symmetric about this. So far, this is what is our point. Later on, we'll continue from here. Okay. Now move to the next tracing. So normally, after identifying the symmetry, we go to the point what happens at origin. So the second step always will be this is tracing at origin. I'm supposed to look what happens at origin, right? So I need to always check this, right? If say for a given function f of 0 comma 0 equals to 0, this implies curve passes through origin. This is what is the meaning. Okay, when you are able to find out that when I put x and y both are 0 0 for a given curve, it means, right, if that makes answer equal to 0, then I understand that yes, the particular curve passes through the origin. Okay, let's do this now. So I'm going to put x equal to y 0 and y equal to 0 in equation 1. Okay, so this implies you put x equal to 0 and y equal to 0 in x cube plus y cube equal to 3 a into x y, right? This implies what happens, everything is 0 because x is 0, y is 0, so f of 0 comma 0 becomes equal to 0. This implies the given curve 1, right, curve number 1 passes through origin. I understand this. Okay, so my second thing, I got to know one more detail about the curve. So I have to draw the curve which is passing through the origin now, and it is also I have to draw in such a way that the curve is symmetric about a specific line, that is y is equal to x. So two steps are over. Let's go to the third step, right? Anyway, I don't have anything to draw now. So once we have something to draw, we'll go back to the graph and we'll draw. Okay, so then we have step number 3. In the step number 3, always you try to, since now I know that it is passing through one of the point, right? That is origin. So as soon as you come to know that, okay, the curve is passing through one of the point, you always try to look at the tangents at that point. Okay, why it is helpful, I'll tell you later. So next is to find, you are going to tracing the tangents at whatever point you found, right? Just now I found that it's passing through origin, so I'm going to write origin. This is my next step. So what do you do? How do you find out a tangent? Always you try to do this. There is a standard procedure, right? What you do, this will be done by you always equate by equating the least degree term, right, of the curve to 0, right? Whichever is the least degree term, you have to equate it to 0. So let's write the equation once just to understand what do you mean by degree. X cube plus y cube equal to 3a into x into y. So if you look at the degrees of the terms, this is how you find out. So x cube, so the power of this whole term, right? X and y are my variable, right? All together, right? Add the powers. So here in the first term I have only x, and the higher power, total power is 3. So this is degree 3. What is this degree? It's also 3. Now what is the degree of this? You see 3 is a constant not counted, a is a constant not counted, x power 1, y also 1, so 1 plus 1 degree 2, right? So that's how. So I need to find out which is the least degree term in the given curve, and I have to equate it to 0. So least degree is 2. This implies I have to equate 3axy should be equated to 0. So this means that x is equal to 0 and y is also equal to 0. Now when you equate these terms, whatever you get is the tangent. Alright, so x equal to 0 means what? So what is y equal to 0, and what do you mean by x equal to 0? Which is the line that has y equal to 0? Y equal to 0 is the x-axis. X equal to 0 is nothing but this is the y-axis. So now I get more detail that, right, the equation, this given curve, right, at origin both x and y axis are the tangents, right? So this implies, right, both x axis and y axis are the tangents, at origin to equation number 1. Now I have to draw the curve in such a way that, right, the required curve has, right, symmetry about y equal to x curve, passes through origin, and the x and y axis are going to be the tangents at origin, right? So I keep getting more and more details about the curve, right, as I proceed. Okay, so that is actually step number 3. Then we'll go to the fourth step. Okay, so the step number 4 is we get few more detail about the curve, right? Now I'm going to check that uh, at what points the curve given crosses x and y axis, right? There can be one intersection, two, three, four, or any number of intersections. It can cut the curves many times. It can cut the x and y axis many times. We need to find out all such points so that I get more detail. So this is this step I'm going to call it as tracing the intersection with coordinate axis. So this means coordinate axis means they are x and y axis. Both together you call them as coordinate axis. Now our intention is just to find out that. So right, I'll write the equation number 1 once again. This is x cube plus y cube is equal to 3ax into y. Right. So as soon as I put x here, so if x is 0, because I'm trying to look at where it is going to cut the y-axis. So x is 0 is the equation of y-axis. Whatever y value you get, right, that's the point where it intersects. This implies that what is the y value in the above equation, right? Y is also 0. Right, it means when x is 0, y is 0, it's a origin. Already we know that. Okay, let me make other change. If y is equal to 0, as soon as I make y equal to 0 in the above equation, x automatically becomes equal to 0. So there is no change in the point. Correct? It actually shows that, right, this implies the curve 1 cuts both the axis, in the sense both x as well as y axis, at origin only. It's not going to cut at any other point. So whatever point we already have found, the curve is going to cut the right or cut the y and x axis only at one point, and that is origin, no other points. Okay, I got few more details now. Let's go ahead. So the next step which we can understand here is, after this, now I know one additional point, that is the curve is symmetric about a given line, right? So when I say that the curve is symmetric about a given line, somewhere the curve has to cut that line, correct? So right, you are understanding that, right? So I'll just go back to the curve. So when I say the whatever curve you are drawing is symmetric about maybe some axis, this means if I draw something like this, it means it has to come from the other side like this, which means you are going to have, it's going to cut at this point, right? You can see that, or this point maybe. So this indicates that now it gives a suggestion to us now, saying that you need to trace out, right, at what point the given curve is going to cut the axis of symmetry. That I need to find now. Okay, so my step number 5 is always tracing the intersection. I have to trace the same thing. So this is tracing the intersection with the curve, that is y is equal to x line. I need to trace this now. Okay, now what we can do, it's actually very simple. You see that the required curve is y equal to x. So what I do, I simply put this relationship, that is put y equal to x in the given equation, that is 1. So in 1, wherever you see y, you put x. So first term is x cube, I keep it as it is. Second term is y cube, but I am going to put x cube, because y equal to x is equal to 3 times a into x into x is x square. All right, this is what is the meaning of this. So this means it is, I can write it as 2 times x cube minus 3 times x square into a is equal to 0. All right, now what I want to do, I will try to take, I can see that x square is common, so take x square out. So when that happens, this is 2x minus 3a equals to 0. See, I have a product and the product is equal to 0. This implies either x square is equal to 0 or the other term is 2x minus 3a is equal to 0. Whenever you have a product equal to 0, it indicates that either both the terms are 0 or one of the term is 0. So one of the term in the sense either x square is 0 or the second term 3x minus. So when I say like this means definitely x is equal to 0. This is one point. Okay, and the other point is uh, okay, it is like this. So 2x equal to 3a. So x is equal to 3a by 2. So the thing is very clear now. The curve is going to cut the y equal to x line at two different points. One point has x coordinate 0, other point has x coordinate 3a by 2. So now how to find out what is the y coordinate, right? It's very simple. So since y is equal to x, right, and x equal to 0, so y is equal to 0. So what is the point where it's going to cut the y equal to x line, right? So the coordinate can be 0 comma 0. This is one coordinate. Okay, and since y equal to x, right, y also equal to 3a by 2, so this implies the coordinate is 3a by 2 comma 3a by 2. It's obvious because y equal to x is the point, right? It's the straight line, so at that particular point they have to meet. Okay, so I got to know about something more now. So let me go back to the diagram so that we can point out something else. Okay, now uh, okay, this is what we already have drawn. Now let us try to trace something more. What I do, I'll copy this and I'll draw wherever we found something. Okay. Okay. Now I'm going to. So this is what we found. We found that okay, at this particular point they are meeting. So I'll paste it. So now let's say this is the origin. I'll mark the origin as, see here, this is okay, this is 0 comma 0, and let me assume there is a point like somewhere here. Okay, so this is the point which is 3a by 2 comma 3a by 2. So now it has to cut this, it will pass through this. We know that the curve is going to pass through this point. That's the first thing, and the second thing is curve is going to pass through 3a by 2 and 3a by 2. So between these two, whatever you draw should be copied on the other side of the y equal to x line. For example, if I draw something like this, then this has to be copied like this. That's what is the meaning. Okay, all right, we'll try to find more details and then we'll be able to draw this. Okay, then let's go further. So far what we have understood, we have written over here. Okay, now in the next step, this will be step number 5 over, sorry, this will be step number 6. In step number 6, we have to trace the asymptotes. So what are asymptotes? Asymptotes are the straight lines, right? They act like the boundary for any given curve. In the sense, the curve is not going to cross these lines at all, from minus infinity to plus infinity. For example, before going to the actual problem, let me say this is a asymptote. Okay, in the sense, if you have a curve something like maybe you may have a curve like this. Okay, so it means you see that the curve is not going to cross this line at all. It may be going to plus infinity. On the other side you may have minus infinity, right? Throughout this it's not going to cross this. Okay, so with the help of this kind of curves, right, sorry, this kind of straight lines, the curve which we are drawing will go to infinity. Okay, in the sense these two, the curve and the straight line is going to meet at infinity. That's the meaning of this. Okay, they are going to meet at infinity, so they can be parallel, or you can consider them to be the lines which take your curve to infinity. Okay, so you can consider him like that. So now if you find such lines, right, then we can decide upon what should be the shape of my curve. Okay, because in which region my curve exists, etc., I can easily find out by using this concept. Okay, so that's why I need to find out this idea that where are the asymptotes. Okay, so always finding the asymptotes is using the following step. Okay, you first write down the given equation: x cubed plus y cubed is equal to 3 into a xy. So in order to find this, the first step is you always put x equal to 1 and the y will be made equal to some constant, say m. Okay, and I write the left hand side equation separately and right hand side equation separately. This is my next step. So what I call this as okay, let me go to the LHS first. The left hand side only, right? I use the above step and I convert this. So I'm going to call this is phi of m, phi of m, sorry, phi of m. This is equal to, so x is nothing but 1, y is a m, so m power is 3. So since the degree is 3, I'm going to call this is phi 3 of m. Okay, and also I will write the RHS, but you remember one thing: when you write the RHS part, you are writing it in such a way that the right hand side is supposed to move to the left hand side, and that sign should be considered. In the sense, now you see it's right on the right hand side, I have a term 3axy, but when I move this to the left side, this becomes minus 3 into a, x is 1, y is m. Okay, so just take care of this thing. So now I give a notation as phi 2 of m, because the on the right hand side, what is the degree you have? The degree I have is equal to 2. So the degree of 3axy is 2. I already know that. That's why I called this as phi 2 of m. Okay. One left hand side equation, one RHS equation. Two equations we need to write. Okay, this is the step number 1 of tracing the asymptotes. Right, then you always equate, right, the highest degree term to be equated to 0. Okay, so in this case, equating phi 3 of m equated to 0. Right, it's always highest degree term. So this implies 1 plus m cube equal to 0. I need to find n, so m, right, cube equals to minus 1. So this means m is equal to the cube root of minus 1. So it's very standard. There are 3 roots of minus 1. So let's write them. So we know this, m is equal to, first root is minus 1 itself. Okay, and the other roots are complex conjugate roots. We know that the roots are 1 by 2 plus or minus j times root 3 by 2. So you can see that there are 2 more roots in this case. First root is minus 1, root number 1. Root number 2 is half plus j root 3 by 2. and the third root is half minus j root 3 by 2. In this case, again, I'm plotting everything in a real graph, so complex roots can be neglected. So I'll just write, if at all you get a root as any root as complex root, what do? You simply write that is neglected. So I'll write here neglect as they are complex. So since they are complex, you simply neglect, which means I have only one root now, that is m is equal to minus 1. So I'm supposed to find out this value of m first, right, using the highest degree term equating it to 0. I got it. The second step is to find out a constant, right? So because you see that the constant is going to be the y-intercept of your line, whatever line you are going to draw now, right, that particular line has a y-intercept, right? So this m is nothing but the slope. Okay, so just write this is the slope m, slope of your asymptote, because asymptote is what? It's a straight line. So slope of the straight line, y equal to mx plus c is what I want, out of which I found the m value, right? To find the y intercept of asymptote, this will be the next step, right? So what I do, I'm calculating a c. So c is equal to, remember one thing, you know the highest degree term that goes to the denominator, and the one term which is lesser than that will come to the numerator. So this is minus, in this case phi 2 is the one lesser degree, and the highest degree is phi 3 of m. Differentiate the denominator. So this is not phi 3, this is phi 3 dash, indicating that you need to differentiate. Okay, so I am differentiating this, that's why I'm writing a phi 3 dash. So this is equal to, so phi 2 is nothing but I know that this is minus 3am, so I'll write minus of, this is minus 3a into m, okay, divided by phi 1 dash. Just see the phi 1 is 1 plus m cube, 1 plus m cube differentiation is 3 into m, sorry, 3m square. So right, I know that m cancels with this, 3 cancels with this, right? I know that there is a m, so I can put the value of m. Now m is equal to how much? M equal to minus 1. I just know now, right? Because previously we calculated. So this c value becomes equal to, minus of minus cancels, I have a divided by m, a by m, with the value of m equal to minus 1. So this is equal to minus a. So the y-intercept is minus a. Right. So once you know the c and m value, I can go for asymptote. Therefore, so if you have multiple values of m, you keep getting multiple values of the asymptote. There may be many asymptotes depending upon the number of m you have. If m is equal to minus 1, m equal to minus 6, etc. If you get, see, when you put m equal to minus 1, you get one curve. M equal to minus 6, other curve, and so on. Like that, you can calculate. Okay, so asymptote equation will be y equal to mx plus c. So substitute, y is equal to, m is minus 1, so this is minus x, plus c is what? C is equal to minus a. So we can see that the curve is y is equal to minus of x plus a. Or maybe you can also write, take the minus x to other side, y plus x is equal to minus a, possible, right? Whichever is convenient to you, you can represent in that way. Okay, so this is the asymptote now. So now I understood that, okay, in the above graph, whatever I'm trying to draw, I have to write this particular straight line. Okay, so let's copy this and let's try to draw the asymptote now. Okay, so this was the curve which we understood that till the previous step. Now I need to identify the point that where will be this a, right? Because okay, I got the line y plus x equal to minus a. Now I need to find out the points where this particular line is going to cut the x and y axis. Okay, once I know that, I can make it more easily I can plot it. So I know that the curve is, what's a curve? Curve is y plus x equal to minus a. So this implies along the x-axis y equal to 0. So when y equal to 0, right, what happens? X is equal to minus a. So the point is minus a comma 0. So mark a minus a comma 0 on this. Okay, so let's assume that this is the point. This is the point where, this is the point minus a comma 0. At the same time, in this given equation, I'll put x equal to 0. X equal to 0 means what happens to y? Y becomes equal to minus a. So this implies the point is 0 comma minus a. So 0 comma minus a is somewhere here. So this is the point where I'm going to write this is 0 comma minus a. Now this particular curve, that is y plus x equal to minus a, will pass through these 2 points. Okay, so let's draw one such curve. So this is the asymptote. That is y plus x equal to minus a curve is this. Okay, now I understand that whatever I am going to draw is going to be present concentrated over here. That's the first point. And my curve should not cross this. There is no question of crossing this line. It should be present on this side only. Maybe you can draw something like that so that it goes to infinity. Okay, that's what is meant by the asymptote, and we found the asymptote of the required curve. All right, okay, there is one more step left before I draw something final, before I draw the final graph. So that is the, I think this should be step number 7. So seventh step is I'm going to trace the region of existence. To trace the region of existence from the above curve, it's very clear that I have to have something in the, maybe in the first quadrant, second and fourth quadrant, but I have a doubt whether I have to draw something here. This is the third quadrant, because definitely whatever you draw here will be drawing here also. So it will definitely, it's going to come in the first, second and the fourth quadrant, but I have a doubt whether I need to draw something in the third quadrant or not, right? That is just because I have some blank space left over here, right? In this blank space, will you write something or not? Okay, that's the point. So just to identify that this is the region of existence, so to check something whether it is there in the third quadrant or not, you have the following test to be conducted. Okay, so the test is like this. What you do, you simply check f of xy and f of minus x and minus y. Okay, so that means if f of x comma y is equal to f of minus x comma minus y, because x comma y in the first quadrant, minus x minus y in the third quadrant. If both are same, it means it will be present in the third quadrant, right? Otherwise it's not, right? If this is the case, this implies it is present in the third quadrant, right? But now you see 1 in the given equation, the f of x comma y is not equal to f of minus x comma minus y. It's not the case, because first is x cube plus y cube equal to something. Now when you make minus x, it becomes minus x cube minus y cube. Right hand side is still same, so they are not equal. So since this is the case, the equation number 1 does not exist in the third quadrant. So I understood, right? Now I have enough details so that I can plot the curve, right? Now let's go back. Let me just copy this and let's draw the curve as a final answer. Okay, now right, so far we understood. Now it's very clear that the curve cannot go to the third quadrant, it cannot be present in the third quadrant. Okay, so let me draw this. So let me change the color. So I know that my curve is going to pass through this point, and it also goes to this point, in the sense from 0 0 to 3a by 2 3a by 2, it will take a path in such a way that at 0 0 my y-axis has to be a tangent. It means it cannot cross your y-axis, because y-axis is a tangent. It means it has to, sorry, it has to start something like this. It can go and it has to reach here. Now this is the only option, such a way that y is a tangent at 0, means this is the only option. At the same time, when it comes back, x-axis becomes a tangent. So it means it has to come in a very, sorry, it has to come in a very similar fashion. Sorry, this is not the way. X-axis should look like a tangent to you. Okay, so something like this. Okay, so it has to be equal on both sides of y equal to x. In addition to this, you see my curve cannot enter the third quadrant, but it has to be lying on the right side of this curve always, and it has to go to infinity. So only option I have is, see, the curve which was tangent to y will be coming, it cannot cross your y-axis because it's a tangent now, so it cannot cross the tangent. It can come like this, and it can go in this way till infinity. At the same time, on the other side, I have to have the same representation. It has to come, sorry, it has to be just like this, 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 and it will go to infinity. Now you see that the y equal to x, whatever I have on this side is actually matched on the other side. That was the requirement. About the y equal to x line, it has to be symmetric. In the sense, if you place a mirror along this line, whatever is on this side should be present on the other side. Same to same. That's the first condition we identified, saying that, okay, the required curve has to have, sorry, the required curve, it's expected to have, right, that kind of symmetric nature. All right, so let's just check whatever we have drawn is correct or not. So let's try to find out. Let's go back and check. All right, so let's look at the first point we discussed. So in the first point, it says that it is symmetry. So it says that the curve is symmetric about the straight line y equal to x. Okay, so now when you check, yes, that is true. This given curve is symmetric about the curve. On the right side, what I have the same thing on the left side about y equal to x line. Okay, then let's go to the second point. just check. So what happens at the origin? Will the curve passes through origin or not? We checked. And how did you check? Put x and y values is equal to 0 in the given curve. If at all, when you put x and y both as 0 0, if the whole equation becomes equal to 0, then it means the curve is going to pass through the origin. Okay, so in this case, in this equation number 1, whenever you substituted, you got that answer. We understood that yes, that particular function becomes equal to 0. That's why I had drawn some curve which is passing through origin. Okay, 0 comma 0, it is passing through 0 comma 0. So second condition is satisfied. Then let's go to the third point. So the third point says, what are the tangents at origin? So how do you find out that? The basic rule is simply take the least degree term. So calculate the degrees of each term, and in this given equation I understand that 3axy is the least degree term and its degree is equal to 2. Other terms have degree equal to 3. So because of that reason, since I am equating the terms, right, of the least degree equal to 0, I have to equate 3axy equal to 0. 3a is constant, so nothing to do with that. It's a constant. It cannot be equal to 0, which means x equal to 0 and y equal to 0 are the answers, what I'm looking for. So this means x equal to 0 is a y-axis, y equal to 0 is the x-axis, right? So at origin, both of them are tangents only, right? Tangents means they are going to touch the curve only at one point, and my curve is not going to touch those two x and y at any other point. That's what is the meaning of this. So what I do now, I will check the third point now in our final graph. You can see that, right, y equal to 0 is a tangent. It's passing through origin only once, right, and at that point itself it is a tangent. It's a tangent for the upper portion of the curve, and the lower portion of the curve is going to pass through origin once again, and at that moment 0 comma 0, at 0 comma 0, x-axis becomes the tangent. So both the curves y and x are tangents like this for the given curve. So that condition is also satisfied. All right, then we try to trace out what is called as, right, intersection. Will there be any other intersection? I understood that, okay, there is one intersection over here. Sorry, it's a point number 3 was that, right, there are two tangents. Now I was checking, I try to trace intersection, whether there is any other intersection happening other than 0 0, right, and I found that, right, I'm going to trace that by, first I put x equal to 0, I get a y coordinate. In this case y is 0. 0 0 comes, which is already known point origin, and when you put y 0, you are expected to get the x coordinate, and in this case x coordinate is 0, which means once again you get only origin as the point of intersection of y and x axis, right, in the whole graph, right. So that's already we have plotted that already. You can see that the curve is going to cut the y and x axis only once, right, between minus infinity to plus infinity. It's going to cut at only one point, only once. So that's also we have taken care of when we drew this graph. So that was point number 4, right, tracing intersection with coordinate axis. Then we'll go to the step number 5. In this particular step, we were looking at the tracing of intersection with the other line, because this particular point might not come in every problem, but you see that in this case we got this particular step because we saw that there is a line about which our curve is symmetric. So remember one thing, whenever somebody says that a curve is symmetric about y-axis, right, curve is going to cut the y-axis somewhere, because it has to be equal on both sides of y, right? So only when you cross the y-axis it becomes symmetric. So same thing happens with the x-axis. If somebody says there is a curve which is symmetric about x-axis, that means your curve is going to cut the x-axis at least once. So in a very similar fashion, now already we have identified for a given curve that curve is symmetric about y equal to x line. That means by default it should indicate that the curve is going to cut this particular line at least once, right? So at least one means more than once possible. You have to find out, right, how many times. Okay, so for that we use this as an additional step for this given problem, that we try to trace the intersection of the curve with y equal to x line. So y equal to x is the characteristic of that line. What you do, you put that condition in your given equation. So you see here x cube plus y cube equal to 3axy. Put y equal to x here, gives you this equation. X cube plus x cube is equal to 3ax square. Right. Simplify. 2x cube minus 3x square a is equal to 0. So x square looks like a common thing for you. You take it out, right? And 2x minus 3a is the other term. So when you have that, you can equate both of them to be equal to 0. So x square equal to 0 indicates that x is 0, which is the only answer. This is the first point, coordinate of the first point where it meets the y-axis. And you can see that on the other side, I have 2x minus 3a is 0, which gives me x equal to 3a by 2. Right. So I got the x coordinate. Now I am supposed to find out the y coordinate of the point. So how do you do that? You use the straight line, because y equal to x is a straight line. And I know that this point, what I am looking for, should be present on that curve, that line itself. So since y is equal to x, whatever you got x, put it for y. So 0, 0 is one answer. 3a by 2, 3a by 2 is the other answer. So we had plotted that over here, showing that yes, right, at 3a by 2, 3a by 2 and 0 comma 0, the curve is going to cut the y equal to x line. So to satisfy this condition, we had plotted like this. So curve should exist between 0, 0 and 3a by 2, 3a by 2 on both the sides of the curve. So what do? You have to draw whatever you draw on one side of the curve should be present on the other side. So since we don't have any idea about what are the other points where the curve is going to exist, you can simply draw it like what we have drawn here. Okay, you draw, start from 0, 0, go till 3a by 2, 3a by 2. Repeat the same thing on the other side of the y equal to x cube. Okay, this is what s is. Now, going further, our next intention is to find out the asymptotes. So as we know already, asymptotes are the lines which takes your curve till infinity, right? With the help of that line, you can say that the curve goes to infinity, right? And there is a standard procedure to do that. So the concept of asymptotes we already have studied somewhere else in some other chapters. So we are directly using that over here. Okay, so what we did, you have the curve equation given. On the left hand side, whatever you have, you write one equation corresponding to that. The lesser degree term will be normally present on the right hand side, right? For that you write another term. So phi or phi 3 of m I call, the 3 indicates the degree is 3, right? When you write that, put x equal to 1 and y equal to m. Okay, using this condition, y by x ratio, you can find the slope. That's why make x equal to 1, y becomes the slope. That's the basic idea in the geometry, right? Coordinate geometry. So we write phi 3 1 plus m cube, and phi 2, when you write a phi 2, take the right hand side to the left hand side. With the sign you write that, so it becomes minus 3a into 1 into m, which is minus 3am, right? Now equate the term to phi 3 highest degree term to 0 to get a value of m. In this case, you can see that the value of m comes to be minus 1 and a complex conjugate. So since your graph is real, you neglect the complex term. So m equal to minus 1 is the only possibility, right? So I'm looking for a y equal to mx plus the straight line, out of which I made m. I know that m value is minus 1, only one value. So now my intention is to calculate a c, right? How to find a c, right? This is the basic idea. It's negative of, right, one lesser degree term equation divided by the differentiation of the highest degree term. So in this case, for this problem, this is the equation, phi 2 of m by phi 3 dash of m. If at all you have, right, phi 4 term, then the denominator will be phi 4 dash of m, numerator will become phi 3 of m. Okay, right, that you can apply for any problem given. All right, now you substitute this and substitute the value of m as -1 because already we have calculated the value of m. So when you simplify that, the y-intercept c becomes equal to -a. So we know that the standard equation of a straight line is y equal to mx plus c. Substitute the values given to get the equation of this y plus x equal to -a. So to plot this line, I put x equal to 0 and get a value of y, and then I put y equal to 0, I get a point of x. So in this case, I get the points like -a comma 0 and 0 comma -e, right? Draw the points on the graph and connect them using a straight line, right? That line we have shown here. And just to clear the doubt of whether I have to draw something in the third quadrant or not, I use the last step, existence of the region in which it is going to exist. And I found that it's not going to be present in the third quadrant at all. I don't have to write anything on the third quadrant. I cannot write it at. So just to satisfy that condition, I continued my curve from 0, 0 in the second quadrant, and it goes to infinity like this. At the same time, fourth quadrant should be a replica of that because it has to be the mirror image, right? On the y equal to x line. So whatever I have drawn here, I have copied the same thing but in the fourth quadrant. I cannot cross the asymptote, so I kept the curve only on one side of that. Okay, so overall this is the final answer of tracing the given curve.